We have logarithm. The first topic is log. Logarithm. That is for the first week of the term. The same thing, second term. Second week. So first and second week for first term in any school, SSU federal government scale is logarithm. Then the third week, let me number them. The third week of that resumption, you have approximation. Approximations. And the fourth week in any school is sequence. And of course, sequence goes with series. So sequence and series. For the fifth week, it's the same sequence and series. For the sixth week, it's quadratic equation. For the seventh week, the same quadratic equation goes on. You have 2 weeks. And for the 80th week, we have now simultaneous linear equation and quadratic scale. Simultaneous equation, linear, of course. Linear equation and quadratic too. For the ninth week, the same thing repeats itself. The same thing repeats itself. Ninth week. Then the 10th week, you now talk of gradient. Gradient of a curve. Gradient of a line. That is exactly what you have. Federal government scheme of work. This is the scheme process too. SS2 maths in any school in Nigeria. The first week is going to be logarithm, second week logarithm, and the third week approximations. The fourth week sequence and series. The fifth week is sequence and series still. Then the sixth is quadratic equation. The seventh still remains quadratic equation, that's for 2 weeks. Then 80th week is simultaneous linear and quadratic equations. The ninth week, the same thing, simultaneous and linear equation, quadratic. Then finally, the 10th week is now gradient of a line. You may ask what happens to 11th or 12th week. Yes, there's always 11th and 12th week in any school for a term. The 11th week will be revision, and the 12th week will be for the examination itself. But the ends studies in 10th week. The 11th week is revision, the 12th week is exam itself. Having gotten the scheme of work, I'm going to start from number 1. I'm going to follow it serially. So for today, I'm starting with logarithm. So logarithm. For short, call it log. Yes, I agree. There's this general impression that mathematics is very difficult. Yes, I don't so much believe in that. I think what matters is the teacher. Ability of the teacher to water it down. Bring it down to the level. Not so it is easy, not so it is difficult. Physics, chemistry, biology, CRN, comment, the same thing, just name it. Now difficult subject. What matters is teacher's methodology. Are you able to water it down, bring it down to the level? If you're able to bring it down, then you carry the student along. Whether it's mathematics, whether it's chemistry. Teach it, bring it down. Don't hurry over it. They will see that all subjects will be made easy. That I think I'm going to do. Logarithm. Log. Let us start in this way. If I give you 10 or even 100, and I say, how many times am I going to times 10 to give me this 100? And 100 is made up of 10 times 10, agreed? And for short, once we under this is 10 to power 2. Permit me, let me share this into 2. It says if I say 1,000, this 10 times 10 times 10, that is 10 to power 3. And of course, that's the standard form. The origin of log starts from standard form. If you remember standard form, have it at the back of your mind. That is what we are going, because it's for us. What of 10 itself? 10 is just once. Now, if you're not talking of a log of a number, you are not going, first of all, remember, what is this number? But basically, and more importantly, what base are you using? Let us now say, most importantly, the base is base 10. If I now look for the log of 100 in base 10, this one is the base. This is the number itself. So I'm looking for the number, log of 100, and the base is base 10. You are asking yourself, using the standard form, how many times are you going to times 10, the base, to give you the 100? I come again. We are looking for the log of 100, that's the number here. And there is base here, base 10. First you now ask yourself, since it's base 10, how many times are you going to times that base to give this number we're looking for? We recall here that 100 means log of 10 times 10 in base 10. And that is 10 squared. In other words, you are looking for log of 10 squared in base 10. Then this, what you call the power here index, becomes your answer. Log of 100 in base 10, where the base is 10, is equal to log of 10 times 10 in base 10. Which is equal to 10 log 10 base 10 to power 2. Automatically, the power here becomes your answer. In other words, therefore, log of 100 in base 10 equals log of 10 squared in base 10. Since the log 10 base 10 is 1, here becomes equals 2. Put it differently, I cannot say that the log of a number in a base is the power we are going to raise that base to give a number. I'll come again. I'm looking for log of a number in a particular base. Equal that base to power what? I'm looking for log of a number and say, what base? And I say, okay, since I'm looking for log of the number, and I say, this base, what power are you going to raise it? So log of number is what base to power what? Since I'm looking for 100, for example, I look at log 100 in base 10, and I say, this 10, the base, what the power I'm going to raise it, the base to give me this number? The base to power what? And that is log of 100 by 10. And therefore that is 2. Therefore, log of 100 in base 10 equals 2. Put it plainly, you cannot say the log of a number. Therefore, conclusive, you cannot say log of a number in base equals the power of the base. Power of the base. Log of a number in base 10 equals power of that base. That is why log of 100 in base 10 gives me the power of 10 to give me this 100. 10 to power 2. So log of 100 in base 2. In the same way also, if I say log of 10 in base 10, I'm going to raise 10 to power 1 to give me 10. Because this 10 itself, there's a silent 1 there. Equals 1. The same thing if I say log 1000 in base 10 equals log of 10 3 times 4. 10 times 10 times 10 times 10 is 1000. So I'm going to raise 10 times in base 10. And automatically the power will be the answer. Therefore, log of 1000 in base 10 equals 3. You can therefore conclusively say that log equals the power of the base. If we cannot con log equals the power of the base. Power of the base. Now let me take it again. We're taking 10, 100, the made of 10 times 10. And that's 10 squared. That's when I now say log of 100, yes. And the base here is 10. Emphasis on the base you're using. So I'm talking about log of 100 in base 10. You now have to say, this base that is 10, how many times am I going to times this base to give me this number I'm looking for the log? Let's say it's 2 times 10 squared. Then automatically the answer is the power. So log equals the power of the base. Therefore equals the power. That's a log of the equals the power of the base. That's why log of 100 in base 10 is 2. In the same 2, if you say log of 10 in base 10, so how many times am I going to times the base 10 to give me this 10? It's once. Now, log of 10 in base 10 is 1. Also, log of 1000 in base 10. Log of 1000 in base 10 means how many? In fact, the number of 0 10 to the power of 10. 1, 2, 3. It's 10 to the power 3. Number of 0 without decimal point. Number of 0 here, how many 0? 2, 1, 2. That was 10 to the power 2. Here, 3, 1, 2, 3. 10 to the power 3. If I say log of, for example, when I say log of 10 to the power 5, log of 1, 2, 3, 4, 5 in base 10. Just log of 10 to the power, count 1, 2, 3, 4, 5. Power 5 in base 10. You answer is just the power 5. So log equals power. That's simply any log and it's Trodian log. The log the power of a base. Now, apart from base 10, we have log in other bases. Logging in other bases, yes. Let me go into logging in other bases. If I come to the laws of logging, there's certain laws governing logging, but then log can also be discussed in other bases. Not just 10, yes. The popular one is 10. We normally use 10, but then there are log in other bases. Now, log in other bases. Apart from base 10, you can also discuss log in other bases. Not just only base 10. It could be base 2, base 3, whatever base you want. Let's take, for example, log in base 2. And somebody say, what is 8 in base 2? Log of 8 in base 2. If you remember what I said in first part, the log of a number means the power of the base. This is the base. What power are you going to raise it? Log to a certain power. I'm looking for a log of 8 in base 2. You are going to ask yourself, the base is what? What power are you going to raise it? The power now becomes your log. E.g. now, I want log of 8 in base 2. And I say, how many times am I going to times 2 to give me this 8? To give me 8 in base 2. And that's 3 times. 2 times times 2. In other, I'm looking for a log of 2 cubed in base 2. And I say, let's say log equals the power. The power of the base is 2. The power is what? That's what 3. Therefore, log of 8 in base 2 is 3. In the same way, like I'll look for log of 16 in base 4. You will not ask yourself, how many times am I going to multiply 4 the base to give me this 16? I say log equals the power of the base. In other words, you are not asking yourself, 4 to base what? This is the base. Power. This is the base. You are not looking for the power. Log of 16 in base 4. Since 4 is the base, 4. To what power before you get 16? Therefore, log of 16 in base 4 equals log of 4 times 4, which is 16 in base 4. And that is log of 4 squared in base 4. And that is just 2. That proves that log equals the power of the base. That's in base 4. I can do it in base 5. Now, if I'm looking for log of 125, for example, in base 5, now ask myself, how many times am I going to multiply this base 5 to give me 125? I will know that it's just 3 times. That's log of 5 to the power 3 in base 5. And that is 3. I can also do it for 9. 81 in base 9. Now, so okay, how many times am I going to apply 9 to give me 81? It's 2 times. Therefore, log of 81 is in base 9 equals log of 9 squared in base 9, which is 2, rather, which is 2. I can also do it for log of 81 in base 3. In base 3. Now ask yourself, how many times am I going to apply this base 3 to give me 81? We know that 3 times 3, 9 times 3, 27 times 3, 81. You know that we are now looking for log of 3 to the power 4 in base 3. And therefore the power here is your answer. Therefore log of 81 in base 3 equals 4. Now we're going to put that log is the power of the base. Whatever base, whether it's base 10, whether it's base 2, for example here, whether it's base 4, whether it's base 5, whether it's base 9, even in base 3. Log is the power you raise the base. Here now, log 125 in base 3 is raise this 5 to a power 3 to give 125 times 5 times 5. And that's 125. That's why log of 125 in base 5 equals 3. For 81, for example, log of 81 in base 9. 81 means 9 times 9, that's 9 squared. Therefore, the answer is 2. Log of 820, the same 820 but in base 3 now. Means I'm going to times 3. How many times? 3 times 3, 9 times 3 plus 7 times. That's 4 times. So I'm looking for log of 3 to power 4 in base 3. And therefore the final answer is 4. So log equals the power of base. These are logs in other bases. Now, let's start coming back. There are certain laws in logarithm. Almost everything has a law, yes. Laws in logarithm. There are certain laws in logarithm. The laws in logarithm. Laws in log. The first one says, under the multiplication law, if you have log of this times log of this, or log of this plus log of this, log of 8 in base 2 plus log of 4 in base 2. So log the bases are the same. The base there base 2, the base there base 2. Under the law, say what you do, go and multiply them. Equals log of 8 times 4, still in the same base 2. That's the first law. If I have log of this plus, if I is this plus, the law say go and multiply. So when you say plus and log, go and times. Now the second law says if it is division now, if I say minus log of 64 in base 2 minus log of 16 in base 2. The subtraction law, here was addition law. When you say log of this plus log of this, it means you are going to times it. But if it's now minus log of 4, log of 64 in base 2 minus log of 16 in base 2, what to do? Since it's subtraction, you go and divide. So log of 64 divided by 16 in base 2. So important thing here is that if it's log of this plus this, you want to do multiply. If it is subtraction, log of the minus what to do in divide. Then the third law, which I would call law, there's not another law. If there's a power, maybe log of 36, I say yes, 6 in base 6, and there's a power here. The law says it's not other law, but I assume it to be a law. Third law, there's nothing wrong if you bring the power first to come before the law. Now this is 2 bring out the power. Log 6 base 6. That's what the third law is saying. If I have log 6 to power in base 6, bring the power to come first. Therefore 2 log 6 base 6. That's third law. The basic laws. Log on the first law it says if I have plus log of this plus log of what you do, multiply them. Also have in second law, log 64 minus log 16. The same, so long they are the same base. Log 61 in base 2 minus log 16 in base 2. What do you divide it? Now, so what is the third law is saying if you have log of this and where the power is here, the same thing as bringing the power first to come before the law equals 2 log 6 in base 6. Now we're going to take some examples now. If I now say examples, 1. If I say log of 8 in base 2 plus log of 4 in base 2. Under the first law, this law says we should multiply them. That gives us log of 8 times 4, the same base 2. This happens if and only if, I repeat, if and only if it's the same base. They're not the same base, no. Therefore, yeah, now looking for log of 32 in base 2. Notice how many times I multiply 32. 2 times 2, 4 times 2, 8 times 2, 16 times 2. Now 5 times 2 times 2, 4, 8, 16 times 2. 2 to the power 5 in base 2. And that gives us a 5. The same thing goes if I now say log of 125 in base 5 minus log of 5 in base 5. Under the second law, the first one is addition. Addition law. This is now a subtraction. Log of 125 in base 5 minus log of this. The second law says we should divide. So this gives us now log of 125 in base 5. Divide. That gives us log of, because they give 5 in base 5, which is 1. Please note. Let me make emphasis here. Note. If I take a log of a number and the base is the same number, answer is 1. And log of maybe a number and the base is the same number, the answer is 1. What do I mean by that? If I'm taking log of 5 in base 5, the answer is 1. The same if I take log of 6 in base 6, the answer is 1. So log of any number and the number remains the same base, the answer is 1. What I've said now, if you are looking for log of 5 in base 5, the answer is 1. If I log of 6 in base 6, the answer is 1. Log of any number, and the base is mainly the same number, the answer must end with 1. These are a few examples. Then, example number 3. If I now give you 3, what's a log of 27 in base 3 plus log of 9 in base 3 minus log of 81 in base 3. If you watch, we are combining both the first and second law. The first law is talking of addition, the second law is talking of subtraction. We are now combining both addition and subtraction. Now the first one says addition, you multiply. And the other one says subtraction, you divide. So I'm going to multiply this and divide by this. So in keeping with the log 1 and 2 combined now, what I'll get, resultant effect of this is, in physics, say resultant times log of 9 divided by 81. In base, the base remains, so long the bases are the same, base 3, base 3, base 3. If this is base 4, no, it does not work. Log of 27 is base 3, log of 9 is base 3, and log of 81 the same base, the same base. Emphasis on the same base that the law applies. If it's not the same base, the law fails, there's no law. Now we'll go on. 9 can cancel. 9 goes there, 1, 9 goes there, 9. Of course, 9 can still go. 9 goes there, 1, 9 goes there, 3. You know that I now have log of 3 in base 3. And remember what I said, note, log of a number, and the same number remains the base, then the answer is 1. And so, my log of 3 in base 3 automatically becomes 1. So the result of whatever I say equal to 1. That's the answer. I take it again. Right. So, log of 27 plus log of 9 in base 3 means you should times them. Then this minus log, it will mean you should now divide by 81. If you can multiply straight and divide the same, you can reduce to the less than 9 goes there, 1, 9 goes there, 9. 9 goes there, 9 goes there, 3. And log of 3 base 3 is 1. These are 2 of the examples. We can take as many as possible.